The possible end of mankind. Modern scientific perspectives on existential threats. Introduction. Since the dawn of civilization, humanity has wondered whether our species will endure forever or whether, like countless forms of life before us, we too will one day disappear from Earth. Throughout history, natural disasters, wars, pandemics, and cosmic events have inspired both fear and curiosity about the future of mankind. While many earlier predictions of the end of the world have proven incorrect, modern science has identified a number of genuine existential risks that deserve careful study. More than 66 million years ago, a massive asteroid struck Earth, triggering one of the greatest mass extinctions in our planet's history. The impact contributed to the extinction of the dinosaurs and approximately 75% of all species living at the time. This catastrophic event dramatically changed the course of evolution and ultimately created opportunities for mammals, including our distant ancestors, to flourish. It also serves as a reminder that no species, however dominant, is guaranteed survival. Human civilization has achieved extraordinary scientific and technological progress over the past century. We have explored the moon, landed robotic spacecraft on Mars, mapped the human genome, developed powerful artificial intelligence systems, and even captured the first direct images of black holes. At the same time, these advances have introduced new challenges. Climate change, nuclear weapons, engineered diseases, cyber warfare, and rapidly advancing artificial intelligence have joined natural hazards as potential threats to the future of civilization. Unlike earlier generations, humanity now possesses scientific tools capable of detecting many dangers before they become disasters. International asteroid surveys continuously monitor near-Earth objects. Satellites observe changes in Earth's climate and atmosphere. Medical researchers rapidly develop vaccines against emerging diseases. Scientists around the world collaborate to understand earthquakes, volcanic eruptions, solar storms, and other natural phenomena that could affect modern society. This video examines the major scientific ideas surrounding the possible end of mankind from the perspective of current knowledge. Rather than promoting fear or speculation, it distinguishes well-established science from science fiction and explores how humanity can reduce many of these risks through research, international cooperation, and technological innovation. What this video explores. The discussion begins by examining the extinction of the dinosaurs and the lessons that Earth's geological history offers about the vulnerability of life. It then considers the rise and decline of ancient civilizations, demonstrating that societies often collapse through a combination of environmental, political, economic, and military factors rather than a single catastrophic event. The video goes on to explore the long-term evolution of the Sun and the distant future of Earth, followed by an examination of asteroid and comet impacts and the remarkable improvements in planetary defense achieved during the 21st century. Climate change, biodiversity loss, and environmental degradation are discussed as serious challenges that threaten human societies even if they are unlikely to cause complete human extinction. Attention is also given to supervolcanoes, earthquakes, Earth's magnetic field, and powerful solar storms that could disrupt modern technological civilization. Emerging biological threats, including naturally occurring pandemics and engineered diseases, are evaluated alongside the continuing dangers posed by nuclear conflict and geopolitical instability. Modern technologies introduce both unprecedented opportunities and significant risks. Artificial intelligence, advanced biotechnology, autonomous weapons, and cyber warfare are transforming civilization in ways that demand responsible governance and international cooperation. Beyond Earth, the video investigates cosmic hazards such as gamma-ray bursts, nearby supernovae, and black holes. While these events capture the public imagination, scientific evidence suggests that most pose extremely small risks on human timescales. The search for extraterrestrial life is also examined using current astronomical knowledge, separating realistic scientific possibilities from popular fictional portrayals. Finally, the video considers one of humanity's greatest ambitions, becoming a multi-planetary civilization. Establishing permanent settlements beyond Earth may one day reduce the risk of a single planetary catastrophe ending human civilization, although enormous scientific, engineering, and economic challenges remain. A message of hope. Although the future presents many uncertainties, history demonstrates humanity's remarkable ability to adapt and overcome adversity. Diseases that once devastated populations have been controlled through medicine. International agreements have successfully reduced ozone depletion. Scientists continue to improve our ability to detect hazardous asteroids, predict natural disasters, and understand Earth's changing climate. The greatest threats facing humanity are not necessarily those beyond our control, but those arising from our own choices. Through scientific research, education, responsible technological development, environmental stewardship, and international cooperation, many existential risks can be reduced. The story of humanity is not merely one of survival but of continuous discovery and innovation. While no civilization can guarantee its future indefinitely, our growing scientific knowledge provides reason for cautious optimism. The future of mankind will depend not only on the forces of nature but also on the wisdom, responsibility, and unity with which we respond to the challenges ahead. The possible end of mankind is therefore not simply a story of catastrophe, it is also a story of resilience, scientific progress, and hope. Understanding the risks that confront us is the first step toward ensuring that future generations continue humanity's journey among the stars. The possible end of mankind. Modern scientific perspectives on existential threats. Part 2. The rise and fall of civilizations, the future of the Sun, and Earth's ultimate fate. The rise and fall of great civilizations. Long before the modern scientific age, powerful civilizations rose to remarkable heights and later declined. The ancient Egyptians built monumental pyramids that still stand after thousands of years. Mesopotamia became the birthplace of writing and organized government. The Indus Valley Civilization developed sophisticated urban planning, while the Greeks and Romans laid the foundations of philosophy, science, law, and engineering. In the Americas, the Maya, Aztecs, and Incas created impressive cities and complex societies. For many years, historians believed that civilizations often disappeared because of a single catastrophic event. Modern archaeological research, however, paints a more complex picture. Most civilizations decline through a combination of factors, including prolonged drought, environmental degradation, crop failures, warfare, political instability, disease, economic difficulties, and social unrest. The fall of these civilizations reminds us that even advanced societies are vulnerable when multiple challenges occur simultaneously. Modern civilization is far more technologically advanced than any that came before it, but it also depends on global supply chains, digital communication, electricity, and international trade. These strengths can also become vulnerabilities if major disruptions occur. Humanity's greatest strength: adaptation. Despite the collapse of many civilizations, humanity itself has survived and continued to progress. Our greatest advantage has always been our ability to adapt. When climates changed, humans developed new agricultural techniques. When diseases spread, medicine advanced. When natural disasters struck, societies rebuilt stronger infrastructure. Every major challenge has encouraged innovation, cooperation, and scientific discovery. This remarkable adaptability gives scientists confidence that humanity can overcome many future threats, provided we prepare wisely and cooperate internationally. The Sun, our life-giving star. Every form of life on Earth ultimately depends on the Sun. It provides the energy that drives weather, supports photosynthesis, and maintains temperatures suitable for life. The Sun is approximately 4.6 billion years old and is currently in the stable phase of its life known as the main sequence. During this stage, hydrogen atoms fuse into helium within the Sun's core, releasing enormous amounts of energy. Although the Sun appears constant, it is slowly becoming brighter. Astronomers estimate that its brightness increases by roughly 10% every billion years. This gradual change will eventually alter Earth's climate on geological timescales. The distant future of Earth. Long before the Sun reaches the end of its life, increasing solar radiation will make Earth progressively warmer. Scientists estimate that in about 1 billion years, temperatures may become high enough for Earth's oceans to begin evaporating significantly. As water vapor escapes into space over immense periods of time, the planet could gradually lose much of its water. Without abundant liquid water, complex life as we know it would become increasingly difficult to sustain. These events are unimaginably far in the future, far beyond the lifespan of human civilization as we know it today, but they demonstrate that Earth's habitability is not permanent. The red giant phase. In approximately 5 billion years, the Sun will exhaust most of the hydrogen fuel in its core. It will then expand dramatically into a red giant. During this stage, the Sun's outer layers will extend far beyond their present size. Mercury and Venus will almost certainly be engulfed. The ultimate fate of Earth is still being studied. Some computer models suggest that Earth could be swallowed by the expanding Sun, while others indicate that it might survive the expansion but become a scorched, lifeless world. Regardless of the exact outcome, Earth's surface will no longer be capable of supporting life. Eventually, the Sun will shed its outer layers, creating a beautiful glowing cloud known as a planetary nebula. Its remaining core will become a white dwarf, slowly cooling over billions of years. Can humanity survive beyond Earth? The distant evolution of the Sun raises an important question. If humanity survives for millions or even billions of years, could our descendants leave Earth? Today this idea belongs to scientific planning rather than science fiction. Robotic spacecraft have explored every major planet in the solar system. Humans have walked on the Moon, while orbiters and rovers continue exploring Mars. Scientists are studying how people might one day establish permanent settlements on the Moon and Mars. Although enormous technical challenges remain, including radiation protection, food production, life support systems, and sustainable energy, many researchers believe that becoming a multi-planetary civilization could improve humanity's long-term survival. In the even more distant future, advanced technologies may enable journeys to planets orbiting other stars, though such missions remain beyond our present capabilities. Looking beyond our solar system, during the past 3 decades, astronomers have discovered thousands of planets orbiting distant stars. Some lie within the so-called habitable zone, where temperatures may allow liquid water to exist. These discoveries have transformed our understanding of the universe. Only a generation ago, scientists could only speculate about planets around other stars. Today, they routinely discover new planetary systems using powerful telescopes in space and on Earth. Future observatories may even detect atmospheric gases that could indicate biological activity on distant worlds. Whether intelligent life exists elsewhere in the universe remains unknown, but modern astronomy has shown that planets are extraordinarily common. The importance of long-term thinking. Most people naturally focus on challenges that may arise during their own lifetime. Governments often plan decades ahead, while scientists sometimes study processes that unfold over millions or billions of years. Understanding the distant future of the Sun reminds us that humanity's story need not end with Earth. If civilization continues advancing peacefully, future generations may possess technologies that are almost unimaginable today. The decisions we make during the 21st century, protecting our environment, investing in science, avoiding destructive wars, and encouraging international cooperation, may determine whether humanity continues progressing toward that distant future. Looking ahead, the Sun's evolution represents the ultimate long-term challenge for life on Earth, but it is not the greatest danger facing humanity today. Far more immediate risks come from within our own solar system. Throughout Earth's history, asteroids and comets have repeatedly collided with our planet, sometimes with catastrophic consequences. In the next part of this video, we will examine asteroid impacts, comets, planetary defense systems, supervolcanoes, and the geological forces that continue to shape, and occasionally threaten, our world. The possible end of mankind, modern scientific perspectives on existential threats. Part 3. Asteroids, comets, planetary defense, and Earth's geological forces. Asteroids and comets, cosmic visitors. Throughout Earth's history, our planet has been bombarded by asteroids and comets. Most are small enough to burn up harmlessly in the atmosphere, creating the spectacular streaks of light we call meteors or shooting stars. Larger objects, however, can survive their fiery descent and strike the Earth's surface with tremendous force. The impact that contributed to the extinction of the dinosaurs 66 million years ago remains the best-known example of the destructive power of such collisions. Although events of this magnitude are extremely rare, they remind us that Earth exists within a dynamic solar system where impacts are a natural part of planetary history. Today, scientists estimate that millions of asteroids orbit the Sun. Fortunately, only a small fraction of them cross Earth's orbital path, and an even smaller number are large enough to threaten civilization. Watching the skies. Unlike our ancestors, modern humanity does not have to wait for an asteroid to appear unexpectedly. Astronomers around the world continuously monitor the skies using powerful ground-based telescopes and space-based observatories. International programs search for near-Earth objects, NEOs, asteroids and comets whose orbits bring them relatively close to Earth. Thousands of potentially hazardous objects have already been identified, and their orbits are calculated with remarkable precision. Each new observation improves scientists' ability to predict where these objects will travel decades or even centuries into the future. While no known large asteroid is expected to collide with Earth in the foreseeable future, astronomers continue searching because many smaller objects remain undiscovered. Planetary defense. Can we prevent an impact? One of the most encouraging developments of the 21st century is the emergence of planetary defense. For the first time in history, humanity is developing technologies capable of altering the orbit of a potentially dangerous asteroid. In 2022, a spacecraft successfully demonstrated that deliberately colliding with a small asteroid could slightly change its orbit. This historic experiment showed that, given sufficient warning, it may be possible to deflect certain hazardous asteroids away from Earth. Scientists are also studying other methods, including gravity tractors, kinetic impactors, and, in extreme circumstances, carefully planned nuclear deflection strategies. Each approach presents significant engineering challenges, but the principle is clear: humanity may no longer be completely helpless against cosmic impacts. The key to successful planetary defense is early detection. The more years of warning available, the smaller the change required to move an asteroid safely away from Earth. Small impacts still matter. Although civilization-ending impacts are exceedingly rare, smaller asteroids can still cause severe regional damage. In 2013, a relatively small asteroid exploded high above the Russian city of Chelyabinsk. The explosion released energy far greater than that of the atomic bomb dropped on Hiroshima. The resulting shock wave shattered thousands of windows and injured more than 1,000 people, mostly from flying glass. Fortunately, the object exploded in the atmosphere before reaching the ground. Had it entered at a different angle or been slightly larger, the damage could have been much greater. The Chelyabinsk event reminded scientists that even relatively small objects deserve careful monitoring. Comets. Less frequent but more unpredictable. Comets differ from asteroids in both composition and behavior. Often described as dirty snowballs, comets consist mainly of ice, dust, and rocky material. As they approach the Sun, heat causes their frozen materials to vaporize, creating the spectacular glowing coma and long tail that have fascinated observers for centuries. Most known comets follow predictable orbits, but some arrive from the distant Oort cloud, a vast region surrounding the solar system. Because these long-period comets may be discovered only months before reaching the inner solar system, they can provide much less warning than asteroids. Fortunately, collisions with large comets are extremely uncommon. Supervolcanoes. Earth's sleeping giants. Not all global catastrophes originate in space. Beneath Earth's surface lie enormous reservoirs of molten rock. Most volcanic eruptions are relatively small and localized, but a few volcanic systems are capable of producing eruptions thousands of times more powerful than ordinary volcanoes. These are known as supervolcanoes. A major supervolcanic eruption could eject vast quantities of ash and gases into the atmosphere. Fine ash could disrupt aviation, contaminate water supplies, and damage agriculture over enormous areas. Sulfur-rich gases could temporarily cool the global climate by reflecting sunlight back into space. Fortunately, such eruptions are extraordinarily rare, occurring on timescales of tens or hundreds of thousands of years. Scientists continuously monitor known supervolcanoes by measuring earthquakes, ground deformation, gas emissions, and other signs of underground activity. While no evidence suggests that any monitored supervolcano is on the verge of an imminent catastrophic eruption, continued observation remains essential. Earthquakes and tsunamis. Earth's crust is divided into massive tectonic plates that move slowly over the planet's surface. Where these plates interact, stress gradually builds until it is suddenly released as an earthquake. Most earthquakes are minor, but powerful events can destroy cities, trigger landslides, damage infrastructure, and generate devastating tsunamis. The 2004 Indian Ocean tsunami and the 2011 earthquake and tsunami in Japan demonstrated how natural disasters can affect millions of people within hours. Modern engineering, earthquake-resistant buildings, tsunami warning systems, and emergency preparedness have greatly reduced casualties in many regions. Nevertheless, earthquakes remain among the most destructive natural hazards because they cannot yet be predicted with precise timing. Living on a dynamic planet, Earth is not a static world. Mountains rise and erode, continents drift across the globe, volcanoes build new land while earthquakes reshape coastlines. These geological processes have operated for billions of years and are essential to maintaining a living planet. Indeed, plate tectonics plays a crucial role in recycling nutrients, regulating atmospheric carbon dioxide over geological timescales, and sustaining the conditions that make Earth habitable. The same forces that occasionally threaten civilization have also helped create the environment in which life evolved. Science reduces risk. Although natural hazards cannot be eliminated, scientific progress has transformed humanity's ability to respond. Satellite monitoring, GPS measurements, seismic networks, volcanic observatories, and international emergency communication systems now provide early warnings for many hazards. Engineers continue developing stronger buildings, improved evacuation plans, and more resilient infrastructure. Every major disaster also provides valuable lessons that improve preparedness for future generations. Looking ahead, while asteroid impacts and geological disasters have shaped Earth's history for billions of years, another challenge is unfolding during our own lifetime. Unlike asteroid impacts or supervolcanic eruptions, this threat is driven largely by human activity. Climate change, biodiversity loss, deforestation, pollution, and the degradation of natural ecosystems are already affecting societies across the globe. These environmental challenges are unlikely to cause human extinction by themselves, but they have the potential to reshape civilization profoundly. In the next part of this video, we will examine the scientific evidence for climate change, the decline of biodiversity, and the environmental choices that may determine humanity's future during the 21st century. Certainly, here is part 4 of your video. This completes part 4. The next section, part 5, will examine pandemics, biotechnology, nuclear weapons, and geopolitical instability, with an emphasis on current scientific knowledge and lessons learned from recent history. The possible end of mankind, modern scientific perspectives on existential threats. Part 4, climate change, biodiversity loss, and the future of Earth's environment. A planet under pressure. Throughout Earth's long history, the climate has never remained completely constant. Ice ages have covered vast regions with glaciers, while warmer periods have allowed forests to flourish in places that are now deserts. These natural changes occurred over thousands or even millions of years and were driven by factors such as variations in Earth's orbit, volcanic activity, and changes in the atmosphere. Today, however, scientists have identified a new and much faster driver of climate change: human activity. Since the Industrial Revolution began in the 18th century, the widespread use of coal, oil, and natural gas has released enormous quantities of carbon dioxide and other greenhouse gases into the atmosphere. These gases trap heat that would otherwise escape into space, gradually warming the planet. Measurements from satellites, weather stations, ocean observations, and ice cores all point to the same conclusion: Earth's average temperature has risen significantly since the late 19th century, and the overwhelming scientific evidence shows that human activities are the primary cause of the recent warming trend. The greenhouse effect. The greenhouse effect is a natural process that makes life on Earth possible. Without greenhouse gases, our planet would be far too cold for liquid water or most forms of life. The problem is not the greenhouse effect itself, but the increasing concentration of greenhouse gases caused by human activities. As carbon dioxide, methane, and nitrous oxide accumulate in the atmosphere, more heat is retained, altering weather patterns around the globe. The consequences include more frequent and intense heatwaves, changes in rainfall, prolonged droughts in some regions, heavier floods in others, stronger wildfires, and rising sea levels caused by the expansion of warming oceans and the melting of glaciers and ice sheets. Rising seas and coastal communities. More than a third of the world's population lives near coastlines. As global temperatures rise, seawater expands and glaciers continue to melt, causing sea levels to rise gradually. Although the increase is measured in centimeters rather than meters over short periods, the long-term effects can be significant. Low-lying islands, coastal cities, river deltas, and important agricultural regions may experience more frequent flooding, saltwater intrusion into freshwater supplies, and increased erosion. Many countries are already investing in sea walls, flood barriers, improved drainage systems, and climate-resilient infrastructure to reduce future risks. Biodiversity. The web of life. Human survival depends not only on technology but also on healthy ecosystems. Forests produce oxygen, absorb carbon dioxide, regulate rainfall, and provide habitats for countless species. Oceans generate much of the oxygen we breathe while supporting fisheries that feed billions of people. Pollinating insects enable the production of many fruits, vegetables, and crops essential to human nutrition. Scientists estimate that Earth is currently experiencing one of the fastest periods of species loss in its history. Habitat destruction, pollution, overfishing, invasive species, and climate change are placing increasing pressure on wildlife across the globe. The disappearance of species is more than an environmental concern. Every species plays a role in maintaining ecological balance. The loss of biodiversity weakens ecosystems, making them less resilient to future changes. Protecting biodiversity therefore protects humanity as well. Deforestation and land degradation. Forests are among Earth's greatest natural resources. They regulate climate, store enormous amounts of carbon, protect water supplies, and support millions of species. Yet large areas of forest continue to be cleared for agriculture, urban development, mining, and infrastructure. Deforestation reduces biodiversity and contributes to climate change by releasing stored carbon into the atmosphere. It can also increase soil erosion, reduce rainfall, and make landscapes more vulnerable to floods and droughts. Around the world, governments, scientists, indigenous communities, and conservation organizations are working to restore damaged forests and promote sustainable land management. Reforestation alone cannot solve climate change, but it is an important part of a broader strategy. Fresh water, a precious resource. Although Earth is often called the blue planet, only a small fraction of its water is available as fresh water for human use. Growing populations, pollution, changing rainfall patterns, and increasing demand for agriculture and industry are placing tremendous pressure on rivers, lakes, and underground aquifers. Water shortages already affect hundreds of millions of people. Future solutions will include improved irrigation methods, wastewater recycling, desalination technologies, better water management, and international cooperation over shared river systems. Ensuring access to clean water may become one of the defining challenges of the 21st century. Pollution beyond climate change. Climate change is not the only environmental challenge. Plastic waste has reached even the deepest ocean trenches and the most remote polar regions. Air pollution contributes to millions of premature deaths each year. Chemical contaminants affect rivers, lakes, soils, and wildlife. Fortunately, many forms of pollution can be reduced through improved technology, stronger environmental regulations, and responsible consumer choices. History demonstrates that environmental progress is possible. During the late 20th century, international cooperation successfully reduced acid rain in many regions and helped begin the recovery of Earth's ozone layer by phasing out ozone-depleting chemicals. These achievements show that global environmental problems can be addressed when nations work together. Is climate change an existential threat? Climate change is one of the greatest long-term challenges facing modern civilization. Most scientists do not expect climate change alone to cause the extinction of humanity. However, it can increase the likelihood of food insecurity, water shortages, migration, economic disruption, and conflict, especially when combined with other global pressures. In this sense, climate change acts as a risk multiplier, making many existing challenges more severe. Reducing greenhouse gas emissions, improving energy efficiency, protecting natural ecosystems, and adapting to unavoidable changes are therefore among the most important tasks facing humanity. Reasons for optimism. Despite the seriousness of these environmental challenges, there are encouraging developments. Renewable energy technologies such as solar and wind power have expanded rapidly. Advances in battery storage, cleaner transportation, sustainable agriculture, and carbon capture research offer additional opportunities to reduce emissions. Many countries have committed to reducing greenhouse gas emissions, while cities around the world are investing in greener buildings, cleaner public transport, and improved resilience to extreme weather. Young people, scientists, engineers, businesses, and governments are increasingly working together to develop innovative solutions. The pace of progress varies from country to country, but history shows that technological innovation can accelerate rapidly when supported by political commitment and public awareness. Looking ahead, environmental change represents one of humanity's greatest long-term challenges, but not all threats arise from nature. Some of the most serious dangers are created by human decisions. The 20th century witnessed 2 world wars, the invention of nuclear weapons, and devastating pandemics. The 21st century adds new concerns, including biotechnology capable of altering living organisms in unprecedented ways. In the next part of this video, we will examine pandemics, engineered diseases, nuclear war, and the geopolitical risks that continue to shape the future of human civilization. The possible end of mankind. Modern scientific perspectives on existential threats. Part 5. Pandemics, Biotechnology, Nuclear War, and Geopolitical Instability. Invisible enemies. Throughout history, some of humanity's greatest enemies have been invisible. Long before modern medicine existed, infectious diseases repeatedly swept across continents, changing the course of civilizations. The plague, smallpox, cholera, influenza, and many other diseases claimed millions of lives. Entire communities were devastated because people had little understanding of how diseases spread. The development of modern medicine transformed this picture. Vaccination, antibiotics, improved sanitation, clean drinking water, and advances in public health dramatically increased life expectancy across much of the world. Diseases that once killed millions became preventable or treatable. Yet microbes continue to evolve, reminding us that humanity's struggle against infectious disease is ongoing. Lessons from COVID-19. The COVID-19 pandemic demonstrated both the vulnerability and resilience of modern civilization. Within months, a newly identified virus spread to nearly every country, disrupting healthcare systems, education, travel, trade, and daily life. Millions of lives were lost, and the global economy experienced one of its greatest shocks since the Second World War. At the same time, the pandemic also showcased extraordinary scientific achievement. Researchers around the world identified the virus, decoded its genetic material, developed diagnostic tests, and created highly effective vaccines in record time. The pandemic highlighted the importance of international cooperation, transparent communication, disease surveillance, and investment in scientific research. It also reminded humanity that preparedness is often less costly than responding to an uncontrolled crisis. Could a future pandemic be worse? Scientists believe that future pandemics are inevitable, although their timing and severity cannot be predicted. New infectious diseases may emerge through natural processes when viruses or bacteria cross from animals into humans. Increasing global travel, urbanization, and environmental changes can accelerate their spread. Modern surveillance systems monitor outbreaks around the world, allowing public health authorities to respond more rapidly than ever before. Continued investment in vaccines, antiviral medicines, rapid diagnostic technologies, and international cooperation remains essential for reducing future risks. Biotechnology. Great promise, great responsibility. Advances in biotechnology have transformed medicine. Scientists can now sequence genomes, edit genes with remarkable precision, develop personalized treatments, and create therapies that were unimaginable only a few decades ago. These breakthroughs offer hope for treating inherited diseases, improving agriculture, and combating previously incurable illnesses. However, powerful technologies also require responsible oversight. Research involving dangerous pathogens must follow strict safety and ethical standards to minimize the risk of accidental release or misuse. Governments, scientific institutions, and international organizations continue working to strengthen biosafety and biosecurity practices. The overwhelming majority of biological research is conducted for peaceful purposes, but maintaining strong safeguards is essential as technology continues to advance. Nuclear weapons, humanity's most immediate existential danger. Among all human-made threats, nuclear weapons remain one of the most destructive. Since the first atomic bombs were used during the Second World War, nations have recognized that a large-scale nuclear conflict could cause catastrophic humanitarian and environmental consequences. Modern nuclear arsenals are vastly more powerful than the weapons used in 1945. A major nuclear war could destroy cities within minutes, cause enormous loss of life, and damage the global economy. Scientists have also studied the possibility of nuclear winter, in which smoke from widespread fires could block sunlight, lower global temperatures, and reduce agricultural production. Although the severity of such effects depends on the scale of any conflict, even a limited nuclear exchange could have consequences extending far beyond the countries directly involved. For this reason, arms control agreements, diplomatic dialogue, and conflict prevention remain critically important. The risk of miscalculation. Not every global crisis begins intentionally. History contains several occasions when misunderstandings, technical errors, or false warnings brought nuclear-armed nations dangerously close to conflict. Improved communication systems, verification technologies, and diplomatic channels have reduced some of these risks, but maintaining trust between nations remains an ongoing challenge. The lesson is clear: preventing conflict is far easier than managing its consequences. Cyber warfare and critical infrastructure. Modern civilization depends on digital networks. Electricity, banking, hospitals, transportation, telecommunications, and emergency services all rely heavily on interconnected computer systems. Cyberattacks have become an increasing concern because they can disrupt essential services without conventional military action. Governments and private organizations invest heavily in cybersecurity to protect critical infrastructure from criminals, hostile states, and other malicious actors. Building resilient digital systems has become an important component of national and global security. Geopolitical challenges. The 21st century faces numerous geopolitical challenges, including regional conflicts, competition over resources, terrorism, economic instability, misinformation, and rapidly changing technologies. While these issues may not individually threaten humanity's existence, they can interact with climate change, pandemics, and economic pressures to increase global instability. History shows that international cooperation has often produced remarkable achievements, including the eradication of smallpox, the protection of the ozone layer, and collaboration in space exploration. These successes demonstrate that global problems can be addressed when nations work together despite political differences. The importance of international institutions. Organizations dedicated to public health, scientific research, humanitarian assistance, and international diplomacy play an essential role in reducing global risks. Disease surveillance networks detect emerging outbreaks. Scientific collaborations improve our understanding of climate, astronomy, and medicine. Humanitarian organizations provide assistance after disasters. Diplomatic institutions help reduce tensions between nations. Although these institutions are not perfect, strengthening international cooperation remains one of humanity's most effective tools for managing shared global challenges. A future shaped by choice. Many natural disasters occur beyond human control. By contrast, nuclear war, cyber conflict, and the misuse of biotechnology are largely determined by human decisions. This distinction offers hope. Through responsible leadership, scientific cooperation, effective diplomacy, and public awareness, many of these risks can be substantially reduced. The future is not predetermined. Humanity has the capacity to learn from history and choose a safer path. Looking ahead, the scientific and technological revolution continues at an extraordinary pace. Artificial intelligence is already transforming medicine, education, transportation, scientific research, and industry. At the same time, experts continue to debate the risks associated with increasingly powerful AI systems and other emerging technologies. In the next part of this video, we will examine artificial intelligence, robotics, autonomous systems, quantum computing, and the opportunities and challenges that these revolutionary technologies may present for the future of mankind. Certainly, here is part 5 of your video. With part 5 complete, the video has now covered Earth's history, ancient civilizations, the evolution of the Sun, asteroid impacts, geological hazards, environmental change, pandemics, biotechnology, nuclear weapons, and geopolitical risks. The remaining parts will focus on advanced technologies, cosmic hazards, the search for extraterrestrial life, and humanity's long-term future beyond Earth. The possible end of mankind. Modern scientific perspectives on existential threats. Part 6. Artificial intelligence, robotics, quantum computing, and the future of technology. The next technological revolution. Throughout history, technology has transformed the way people live. The invention of the wheel, the printing press, the steam engine, electricity, the telephone, the computer, and the internet each marked turning points in human civilization. Today, humanity is entering another revolutionary era. Artificial intelligence (AI), advanced robotics, quantum computing, biotechnology, and autonomous systems are developing at an unprecedented pace. These technologies have the potential to improve human life dramatically, but they also introduce new challenges that require careful management. Unlike earlier inventions, many modern technologies are capable of learning, adapting, and making increasingly complex decisions. This raises important scientific, ethical, and social questions about how they should be developed and governed. What is artificial intelligence? Artificial intelligence refers to computer systems designed to perform tasks that normally require human intelligence. These tasks include recognizing speech, understanding language, identifying patterns, solving problems, translating languages, creating images, assisting scientific research, and supporting decision-making. AI is already used in hospitals to help detect diseases, in agriculture to improve crop yields, in transportation to optimize traffic, and in astronomy to analyze enormous amounts of data collected by powerful telescopes. Rather than replacing human intelligence, today's AI often serves as a tool that helps people perform complex tasks more efficiently. AI in scientific discovery. Artificial intelligence is accelerating scientific research in remarkable ways. Researchers use AI to predict the structure of proteins, analyze climate data, search for new medicines, detect distant galaxies, monitor wildlife populations, and improve weather forecasting. In medicine, AI assists doctors by identifying patterns in medical images that may indicate disease. In engineering, it helps design more efficient materials and energy systems. In environmental science, AI processes satellite observations to monitor forests, oceans, and glaciers. These applications demonstrate how AI can become a powerful partner in solving some of humanity's greatest challenges. The challenges of artificial intelligence. Despite its enormous potential, AI also presents genuine concerns. Powerful AI systems can generate convincing text, images, audio, and video, making it increasingly difficult to distinguish authentic information from fabricated content. This can contribute to misinformation and public confusion. Automation may also transform employment by changing the nature of many occupations. While technology often creates new jobs, it can also eliminate others, requiring education systems and governments to help workers adapt to changing economic conditions. Researchers also study the possibility that future AI systems could become increasingly autonomous. Most experts believe that careful design, testing, transparency, and human oversight are essential to ensure that advanced AI remains beneficial. The challenge is therefore not simply building more capable AI, but building AI that remains safe, reliable, and aligned with human values. Robotics and autonomous machines. Robots have already become an essential part of modern industry. They assemble automobiles, manufacture electronics, perform delicate surgical procedures, explore dangerous environments, and assist during natural disasters. Space exploration provides some of the most inspiring examples. Robotic spacecraft have explored every major planet in our solar system. Rovers continue investigating the surface of Mars, while probes have landed on asteroids and comets, collecting invaluable scientific data. Future generations of robots may help construct lunar bases, maintain spacecraft during long missions, and assist astronauts exploring distant worlds. On Earth, robots may increasingly perform hazardous tasks such as firefighting, deep-sea exploration, nuclear facility maintenance, and search and rescue operations following earthquakes. Autonomous weapons. One of the most debated applications of artificial intelligence involves autonomous weapons. These systems are designed to identify and engage targets with varying degrees of human supervision. Supporters argue that autonomous systems may reduce risks to soldiers and improve defensive capabilities. Critics raise serious ethical, legal, and humanitarian concerns regarding accountability, unintended escalation, and the potential misuse of such technologies. Many governments, scientists, and international organizations continue discussing how these systems should be regulated. The goal is to ensure that technological progress strengthens global security rather than undermining it. Quantum computing. Among the most exciting emerging technologies is quantum computing. Unlike traditional computers, which process information using bits represented as either 0 or 1, quantum computers use quantum bits, or qubits, that can exist in multiple states simultaneously under specific conditions. Although still in the early stages of development, quantum computers may one day solve certain scientific and mathematical problems far faster than today's most powerful supercomputers. Potential applications include discovering new medicines, designing advanced materials, improving weather and climate models, optimizing transportation systems, and enhancing scientific simulations. At the same time, quantum computing could eventually challenge existing methods of digital encryption, motivating researchers to develop new forms of secure communication. The digital society. Modern civilization depends upon digital technology more than ever before. Financial systems, transportation networks, communication infrastructure, healthcare, education, manufacturing, and scientific research all rely on computers and global information networks. As technology becomes increasingly interconnected, protecting privacy, cybersecurity, and the reliability of critical infrastructure becomes even more important. Building resilient digital systems is therefore not merely a technical challenge but an essential requirement for maintaining modern civilization. Ethical responsibility. Scientific discoveries themselves are neither inherently good nor evil. The same technology can often be used for beneficial or harmful purposes depending on human choices. Nuclear physics led both to nuclear power generation and nuclear weapons. Biotechnology has produced life-saving medicines while requiring strict safeguards against misuse. Artificial intelligence offers extraordinary opportunities while demanding responsible development. History repeatedly demonstrates that wisdom must advance alongside technology. Education, ethical leadership, international cooperation, and transparent scientific research are essential for ensuring that innovation benefits humanity as a whole. Reasons for optimism. Despite understandable concerns, there are strong reasons to remain optimistic. Artificial intelligence is helping scientists discover new medicines, improve disaster forecasting, reduce energy consumption, accelerate climate research, and expand educational opportunities. Robotics is making dangerous work safer. Quantum research promises revolutionary advances in science and engineering. Space technology continues to deepen our understanding of the universe. Every generation has faced fears about transformative technologies. While caution is necessary, history shows that societies are capable of adapting to profound technological change through thoughtful governance and scientific responsibility. Looking ahead, while humanity continues to develop powerful new technologies, the universe itself presents challenges that lie far beyond our control. Massive stars occasionally explode as supernovae. Rare gamma-ray bursts release extraordinary amounts of energy. Black holes, neutron stars, and other exotic objects reveal the immense power of the cosmos. Most of these phenomena occur at distances so vast that they pose little danger to Earth. Nevertheless, understanding them provides valuable insight into our place in the universe and helps scientists assess the true scale of cosmic risks. In the next part of this video, we will explore black holes, gamma-ray bursts, supernovae, extraterrestrial life, and the fascinating question of whether humanity is alone in the universe. Possible end of mankind. Modern scientific perspectives on existential threats. Part 7. Black holes, gamma-ray bursts, extraterrestrial life, and cosmic hazards. A vast and dynamic universe. Earth may seem enormous from a human perspective, but in the universe it is a tiny world orbiting an ordinary star in one of hundreds of billions of galaxies. Modern astronomy has revealed a universe that is approximately 13.8 billion years old and contains hundreds of billions of galaxies, each with billions of stars and countless planets. Every night, telescopes observe phenomena that challenge our imagination: exploding stars, colliding galaxies, supermassive black holes, and mysterious bursts of high-energy radiation traveling across billions of light years. Although these events appear dramatic, the immense size of the universe provides Earth with a remarkable degree of protection. Most cosmic catastrophes occur so far away that they pose no danger to our planet. Even so, understanding these phenomena helps scientists evaluate the long-term risks that life on Earth may face. Black holes, nature's most extreme objects. Black holes are among the most fascinating objects in the universe. They form when very massive stars exhaust their nuclear fuel and collapse under their own gravity. If enough mass remains after the collapse, gravity becomes so strong that nothing, not even light, can escape from within a boundary known as the event horizon. For many decades, black holes remained purely theoretical objects predicted by Albert Einstein's theory of general relativity. That changed dramatically in 2019, when astronomers working with the Event Horizon Telescope released the first direct image of a black hole's shadow. In 2022, they followed this achievement with the first image of the supermassive black hole at the center of our own Milky Way galaxy. These remarkable observations confirmed predictions that had existed for more than a century. Could a black hole destroy Earth? Science fiction often portrays black holes wandering through space and swallowing entire planets. Fortunately, reality is much less alarming. No known black hole is traveling toward the solar system. The supermassive black hole at the center of the Milky Way is about 26,000 light-years from Earth and poses no threat to our planet. If, hypothetically, a stellar mass black hole were to pass through the solar system, its gravitational influence would certainly disturb planetary orbits. However, the probability of such an event occurring during the lifetime of humanity is considered extraordinarily small. Current astronomical observations provide no evidence that black holes represent a realistic existential threat to modern civilization. Supernovae, the death of massive stars. Not all stars end their lives quietly. Massive stars eventually explode in spectacular events known as supernovae. For a short time, a single exploding star may outshine an entire galaxy. Supernovae create and disperse many of the heavy elements essential for life, including iron, calcium, oxygen, and other elements found in rocks, plants, animals, and even the human body. In a very real sense, every person on Earth is made of material forged inside ancient stars. A nearby supernova could expose Earth to increased radiation, potentially affecting the atmosphere and life. Fortunately, astronomers know of no massive star close enough to present an imminent danger. Gamma-ray bursts. Among the most energetic events known in the universe are gamma-ray bursts. These brief but extraordinarily powerful explosions release enormous quantities of energy within seconds. Some originate from collapsing massive stars, while others result from collisions between neutron stars. If a powerful gamma-ray burst occurred close to Earth and its narrow beam were directed toward our planet, it could significantly damage the ozone layer, increasing harmful ultraviolet radiation reaching the surface. Fortunately, such an event is considered extremely unlikely. The nearest known candidates capable of producing these bursts are at distances where they are not expected to threaten Earth. Astronomers continue studying gamma-ray bursts to better understand their origins and assess their true level of risk. The search for extraterrestrial life. One of humanity's oldest questions remains unanswered. Are we alone in the universe? The discovery of thousands of planets orbiting other stars has greatly strengthened the possibility that life may exist elsewhere. Scientists search for life in several ways. Within our own solar system, robotic missions investigate Mars and study icy moons such as Europa and Enceladus, where liquid water may exist beneath frozen surfaces. Beyond the solar system, astronomers examine the atmospheres of distant planets, searching for gases that might indicate biological activity. Radio telescopes also search for possible technological signals from intelligent civilizations, although none has yet been confirmed. The Fermi paradox. If intelligent civilizations are common, why have we found no convincing evidence of them? This puzzle is known as the Fermi paradox. Several explanations have been proposed. Perhaps intelligent civilizations are extremely rare. Perhaps technological civilizations usually exist for relatively short periods. Perhaps the distances between stars make communication extraordinarily difficult. Or perhaps we simply have not searched long enough using sufficiently advanced instruments. At present, scientists do not know the answer. The absence of confirmed evidence should not be interpreted as evidence that intelligent life does not exist. Could aliens threaten humanity? Popular films frequently portray hostile extraterrestrial invasions. While such stories make exciting entertainment, there is currently no scientific evidence that Earth has been visited by intelligent extraterrestrial civilizations. The enormous distances between stars present formidable challenges for interstellar travel. Even traveling at speeds far beyond those achieved by today's spacecraft, journeys between neighboring star systems would require many years or decades. Scientists therefore regard alien invasions as speculative fiction rather than realistic scientific scenarios. The scientific search for extraterrestrial life remains focused on evidence rather than imagination. The universe is more wonderful than frightening. Although the universe contains extraordinary phenomena, modern astronomy offers reassurance as well as inspiration. The vast majority of stars, galaxies, black holes, and other cosmic objects are unimaginably distant from Earth. Their greatest impact on humanity is not danger but knowledge. By studying them, scientists have measured the age of the universe, discovered gravitational waves, photographed black holes, identified thousands of planets beyond our solar system, and deepened our understanding of the laws of nature. Every discovery reminds us that curiosity, observation, and scientific reasoning continue to expand humanity's view of the cosmos. Looking ahead, having examined the greatest natural, technological, environmental, and cosmic risks, one final question remains. Can humanity avoid these dangers and continue its journey beyond Earth? Many scientists believe the long-term survival of our species may depend upon becoming a multi-planetary civilization, one capable of living not only on Earth but eventually elsewhere in the solar system and perhaps one day among the stars. In the final part of this video, we will explore humanity's future in space, the possibility of becoming an interplanetary species, and the reasons why, despite all the challenges we face, there remains strong scientific grounds for hope. The possible end of mankind. Modern scientific perspectives on existential threats. Part 8. Humanity's future beyond Earth and reasons for hope. Becoming a multi-planetary civilization. For nearly all of its existence, humanity has lived on a single planet. Earth has provided everything our species has needed: air, water, food, energy, and a stable environment in which civilization could flourish. However, relying on a single planet also presents a long-term risk. A global catastrophe, whether natural or human-made, could threaten the future of civilization. For this reason, many scientists believe that establishing self-sustaining human settlements beyond Earth would improve humanity's long-term chances of survival. The Moon is likely to become humanity's first permanent outpost beyond Earth. Its proximity makes it an ideal location for testing life support systems, resource utilization, and technologies needed for deeper space exploration. Mars represents the next great challenge. Although its environment is harsh, it offers day-night cycles similar to Earth's, frozen water at its poles and beneath its surface, and geological features that suggest a fascinating ancient history. Establishing a permanent settlement on Mars would require reliable energy systems, food production, radiation protection, and the ability to manufacture essential materials using local resources. Success will not come quickly, but each advance will expand humanity's ability to live beyond its home planet. Exploring the solar system, humanity's future in space extends far beyond the Moon and Mars. Robotic missions continue to explore the outer planets and their moons. Europa, a moon of Jupiter, and Enceladus, a moon of Saturn, contain oceans beneath their icy surfaces. These hidden oceans are among the most promising places to search for extraterrestrial microbial life within our solar system. Future explorers may establish scientific research stations on these worlds, much as researchers today work in Antarctica. Asteroids may also become valuable sources of metals and other resources needed for future space industries. Technologies developed for asteroid mining could one day support large-scale space habitats and deep space missions. Reaching the stars. Even if humanity successfully colonizes the solar system, the stars will remain our greatest frontier. The nearest star system, Alpha Centauri, lies more than 4 light-years away. With today's spacecraft, such a journey would take tens of thousands of years. Scientists are investigating advanced propulsion concepts, including fusion propulsion, laser-driven light sails, and other technologies that could dramatically reduce travel times. While these ideas remain under development, history reminds us that many achievements once considered impossible eventually became reality. The dream of reaching another star may not belong to our generation, but it could become the achievement of future civilizations. The power of science. Every chapter of this video has highlighted one central truth: science is humanity's greatest tool for understanding and reducing risk. Astronomers monitor near-Earth asteroids. Geologists study earthquakes and volcanoes. Climate scientists improve our understanding of environmental change. Medical researchers develop vaccines and treatments for emerging diseases. Engineers design safer infrastructure. Computer scientists work to develop secure and beneficial artificial intelligence. None of these efforts can eliminate every danger, but together they greatly increase humanity's resilience. Knowledge transforms uncertainty into preparation. The importance of global cooperation. Many existential risks ignore national borders. Asteroids do not recognize political boundaries. Pandemics spread across continents. Climate change affects the entire planet. Cybersecurity, artificial intelligence, and nuclear stability require international dialogue and cooperation. Throughout history, humanity has achieved remarkable successes when nations work together. Scientific collaboration has eradicated smallpox, reduced ozone depletion, expanded space exploration, and accelerated medical discoveries. The challenges of the future will require the same spirit of cooperation. The responsibility of every generation. Each generation inherits the achievements and mistakes of those who came before. The decisions made today regarding education, scientific research, environmental protection, responsible technology, and peaceful international relations will influence the lives of future generations. Young people entering science, engineering, medicine, education, and public service today may become the individuals who solve problems that currently seem impossible. History repeatedly shows that progress often begins with curiosity, determination, and the willingness to challenge accepted limits. A balanced perspective. It is easy to become overwhelmed when considering existential risks. Natural disasters, climate change, nuclear weapons, pandemics, and emerging technologies all present genuine challenges. However, focusing only on danger gives an incomplete picture. Humanity has repeatedly demonstrated an extraordinary capacity to adapt. We have survived ice ages, volcanic eruptions, devastating epidemics, world wars, and countless natural disasters. We have expanded scientific knowledge at an unprecedented rate, extended average life expectancy, reduced extreme poverty in many regions, and explored worlds that previous generations could only imagine. These achievements provide strong reasons for cautious optimism. The future is not predetermined. One of the most important lessons of modern science is that the future depends on probability rather than certainty. Some risks are extremely unlikely but potentially catastrophic. Others are highly probable but manageable through planning and innovation. Understanding these differences allows governments, scientists, and societies to make informed decisions rather than reacting to fear or misinformation. The future will be shaped not only by natural events but by human wisdom, creativity, and cooperation. Conclusion. The story of humanity is far from over. From humble beginnings on the plains of Africa, our species has learned to cultivate crops, build civilizations, unlock the secrets of DNA, explore the solar system, photograph black holes, detect gravitational waves, and develop technologies that once belonged only to science fiction. The challenges ahead are real. Climate change, pandemics, nuclear weapons, emerging technologies, and natural disasters all deserve careful attention. Yet history demonstrates that humanity is remarkably resilient when guided by science, reason, and cooperation. The possible end of mankind should not be viewed as an inevitable prophecy but as a scientific question that encourages preparation rather than fear. By understanding the risks we face and working together to reduce them, we increase the likelihood that civilization will continue to flourish. Perhaps one day our descendants will look back upon the 21st century as the period when humanity first learned to safeguard its future, not only on Earth but throughout the solar system and, eventually, among the stars. If that future becomes reality, the greatest legacy of our generation will not be the challenges we faced, the possible end of mankind, modern scientific perspectives on existential threats. Part 9. Preparing for the future, how humanity can prevent its own extinction. Introduction. Throughout this video, we have examined many of the natural and human-made threats that could affect the future of civilization. Asteroid impacts, climate change, pandemics, nuclear war, artificial intelligence, and cosmic hazards each present different challenges. Some are extremely unlikely but potentially catastrophic, while others are already influencing our world. Yet one important message has emerged repeatedly: the future is not predetermined. Unlike the dinosaurs, humanity possesses intelligence, scientific knowledge, and the ability to cooperate on a global scale. These qualities do not guarantee our survival, but they give us opportunities that no previous species has ever possessed. The greatest question is not whether dangers exist. They certainly do. The real question is whether humanity will use its knowledge wisely. Science, our greatest shield. Every major advance in civilization has been built upon scientific discovery. Science has enabled us to understand diseases, predict eclipses, forecast hurricanes, detect dangerous asteroids, produce abundant food, explore space, and communicate instantly across the globe. Future scientific research will be equally important. Improved climate models may help societies prepare for extreme weather. Advanced medical research may prevent future pandemics. Space telescopes may detect hazardous asteroids decades before they approach Earth. Artificial intelligence may accelerate discoveries in medicine, engineering, and environmental protection. Investment in science is therefore not simply an investment in knowledge, it is an investment in humanity's long-term survival. Education and critical thinking. Knowledge alone is not enough. Societies also need citizens who can evaluate evidence, distinguish reliable information from misinformation, and make informed decisions. Education encourages curiosity, creativity, and problem-solving. These qualities are essential for addressing complex global challenges. The scientists, engineers, doctors, teachers, and leaders of tomorrow are the students of today. Every investment in education strengthens humanity's future. Protecting our planet. Earth remains the only known planet capable of supporting complex human civilization. Protecting its ecosystems is therefore one of humanity's most important responsibilities. Reducing pollution, conserving forests, protecting oceans, restoring wildlife habitats, and using natural resources responsibly all contribute to a healthier and more resilient planet. Transitioning toward cleaner energy sources, improving energy efficiency, and developing sustainable agriculture can reduce environmental pressures while supporting economic growth. Protecting Earth is not an obstacle to human progress, it is an essential part of it. Strengthening global health. The COVID-19 pandemic demonstrated how rapidly infectious diseases can spread in our interconnected world. Future preparedness will require stronger disease surveillance, improved public health systems, rapid vaccine development, international cooperation, and continued investment in medical research. Hospitals, laboratories, universities, and public health organizations all play critical roles in protecting humanity against future outbreaks. The lessons learned from recent pandemics provide valuable guidance for the future. Responsible technology. Technology will continue transforming civilization. Artificial intelligence, Biotechnology, robotics, quantum computing, and space exploration offer enormous opportunities to improve human life. However, technological progress must be accompanied by ethical responsibility. Governments, researchers, industries, and international organizations should work together to establish standards that encourage innovation while reducing unnecessary risks. Responsible governance allows society to benefit from powerful technologies without losing sight of human values. International cooperation. Many existential risks cannot be solved by individual nations acting alone. Climate change affects every continent. Asteroids threaten the entire planet. Pandemics spread across borders. Cybersecurity requires international collaboration. Scientific cooperation has repeatedly demonstrated its value. Researchers from many countries routinely work together on space exploration, climate science, medicine, and astronomy. Although political disagreements will always exist, shared global challenges provide strong reasons for continued cooperation. Humanity's greatest achievements often occur when nations unite in pursuit of common goals. Expanding into space. Becoming a multi-planetary civilization may represent one of humanity's most important long-term objectives. Permanent settlements on the Moon and Mars would not replace Earth, but they could increase the resilience of civilization. Future generations may build scientific bases, industrial facilities, and eventually self-sustaining communities beyond our home planet. In the centuries ahead, advances in propulsion, energy production, and life support technology may even make interstellar exploration possible. Although these ambitions remain challenging, history shows that exploration has always expanded humanity's horizons. Looking 100 years ahead. Predicting the future is never easy. Nevertheless, several trends seem likely. Renewable energy may become the dominant source of electricity. Artificial intelligence may assist doctors, scientists, and educators on an unprecedented scale. Medical advances may eliminate diseases that remain difficult to treat today. Space exploration may establish permanent human habitats beyond Earth. Scientific discoveries that seem extraordinary today may become routine for future generations. The pace of technological progress suggests that the 22nd century may be as different from today as the present is from the early 20th century. Looking 1,000 years ahead. If civilization remains peaceful and continues advancing, humanity may spread throughout the solar system. Large rotating space habitats could support millions of people. Mining asteroids may provide resources for space industries. Powerful telescopes may discover unmistakable evidence of life elsewhere in the universe. Future civilizations may possess scientific knowledge that we cannot yet imagine. While such possibilities remain speculative, they illustrate the extraordinary potential of long-term human progress. Looking 1 million years ahead. No one can predict humanity's distant future with certainty. Our descendants may evolve biologically, enhance themselves through technology, or establish civilizations around other stars. They may explore regions of the galaxy that are currently beyond our reach. By then, Earth may be remembered as the birthplace of a civilization that eventually spread far beyond its original home. Whether this vision becomes reality depends upon the choices humanity makes today. Final reflections. The possible end of mankind is not merely a question about disaster. It is a question about responsibility. Every generation inherits a world shaped by those who came before and leaves behind a world for those yet to come. Science has revealed many dangers, but it has also revealed extraordinary opportunities. Our future will depend upon curiosity instead of ignorance, cooperation instead of conflict, and wisdom instead of fear. The universe is vast, beautiful, and filled with mysteries waiting to be explored. Whether humanity remains confined to one small planet or one day journeys among the stars is a story that has not yet been written. Each generation holds the pen. The decisions we make today may determine whether the human story ends on Earth, or continues across the cosmos for millions of years to come. The wisdom, courage, and determination with which we overcame them,